Hello, DevOps Days. Woo. I'm very excited to be here. Whoops, sorry. So, let's get started. Welcome to the Scale Restaurant, a place that serves hundreds of thousands of clients each day. It all started with one chef, making amazing dishes with basic ingredients. As his business grew, he hired more people, bought more pans and pots and knife sets. But he forgot one thing. He forgot to buy more cutting boards. And that means every time a new worker needed to cut anything, he needed to wait. And that's, my friends, what we call a bottleneck. Today, I'm going to talk about one bottleneck we solved at HoneyBook about managing webhooks at scale. So, hi there. My name is Navon, and I'm a senior DevOps engineer at HoneyBook. I really like board games, and in fact, I like them so much that I'm also the community lead of board games at HoneyBook. I'm also the community lead of Friends of Dorothy, which is an LGBTQ+ community, which is part of the Merge Forward. We're a CNCF community, and we come to help people, individuals, underrepresented ones, to go and do amazing things, like go talk in KubeCon, or contribute to amazing projects like Kubernetes. So let's talk a bit about HoneyBook, but I promise you it is relevant for the context. HoneyBook is an all-in-one client flow system that helps businesses, small businesses and medium ones in the US and Canada to ship and to manage their funnel. From inquiring new leads to signing contracts online, we help them manage all of their funnel. Let's talk a bit about how we manage our customers' money in production. Well, when a new customer comes in and pays to one of the business owners we serve, he sends a request. He sends a request to our payment service. Our payment service then sends a payment request to Stripe, which is the third party we use for payments. And then Stripe sends us back webhooks. That's the situation in production, but what about staging? Well, in staging, we don't have only one environment. We have many environments. We have dynamic environments, and every developer can create a new environment every second by just clicking a button. So sometimes we have more than 50 dynamic environments running in parallel. All need those webhooks. And we not only have Stripe that sends webhooks, we also have many integrations sending webhooks as well. Let's get back to what we did when we had one developer, like the chef I talked about. Well, when we had one developer working on the Stripe integration, we configured one environment for him to test his features. And we also configured our E2E. So we will check those features well, because this is a core functionality. Those are the payments of our product at HoneyBook. But all of the other environments, well, they used mock and not the real implementation. If it will work, of course. Whoops. No. OK, whoops, sorry. Yeah, they use mocks. And that's how we tackled our bottleneck. New people came in, new developers, and also Stripe gave us a limitation of only 16 webhook endpoints. So only one developer could work on the integration, and the E2E env could work only one in parallel, and not more than that. And you might ask me, well, you have 16, why only one? Well, that's because one went to the environment we configured, one went to our E2E, but all of the other went to our principal engineer that forgot to erase his tests from our Stripe account. This is the engineer, by the way. OK, so we understood we need a solution that will distribute our webhooks, that will get them listen to the webhooks from Stripe, and then send them to all of our dynamic environments. Let's talk a bit about our project requirements. First, we want a one-to-many HTTP forwarder. Second, we want it to be observable and lightweight, because we want it to take us less time than it takes them to wait right now. We also want it to be fault tolerance, because, as I said, it's a core feature at HoneyBook. Our payments is everything. But we do only need to ensure at least one delivery, and not exactly one delivery, because our code is idempotent, and it means that if a webhook comes twice, a duplicate of the webhooks, our code will know how to manage it. To solve all of those, we chose to use NATS. So what is NATS? Well, NATS is a very simple message queue written in Go. It's very simple to use. You just run something really nice that the friends here showed me called Docker. And you have a container of NATS. And then you can just connect to it, subscribe to a subject, and publish. No other configuration required. That means Zookeeper, well, no more. It also gives us at least one delivery. And it's also very, very scalable. It's production proof, and in fact, it's CNCF graduated, which means other companies use it in production. But it does manage everything in memory, which means if it falls, we will lose the webhooks. To solve this, luckily for us, we have Jetstream, which is the built-in persistent engine for NATS. You just run NATS with -js, and you have Jetstream. You add a volume, and you have persistency. It also gives us exactly one delivery, because now we have ACK on every message. And it gives us a couple of more features, like a key value store above NATS, and object storage above NATS. It also gives us to configure data retention, so we will be able to store only the data we want, only the amount of data we want. And it gives us out-of-the-box data deduplication, which means we get cost savings for free. So we understood we want to use Jetstream, but what we listen to the webhooks from Stripe, get them into our Jetstream, and then get those webhooks from Jetstream to all of our dynamic environments. So we looked at a few solutions. Some of them were overkill, like Airflow, or Knative, or Tecton. Now, don't get me wrong, they can do the job, but they require maintenance and a lot of configuration. So we looked at the more interesting solutions, like Argo Events or building our own solution. So we already used Argo CD in our both production and staging environment. And Argo Events is from the same parent project. So we decided to start with Argo Events. So let's talk a bit about what is Argo Events. Well, Argo Events is an event-driven workflow automation for Kubernetes. It is it's built from three main components. The first one is the event source. An event source is just a pod that comes up and listens to events. It can be Stripe messages, Stripe webhooks, just as we needed. It can also be NATS events that just got in, but it can also be simple stuff like Slack messages. After we get the event, we will need to store it somewhere, and that's where Argo Events gives us an event bus. Event bus is just something that Argo Events wrap, a message queue that Argo Events wrap, and it can be many things. It can be NATS or Jetstream or Kafka. After we get the event into our event bus, we can sense it and trigger something. We can sense it with sensors and trigger anything from AWS Lambdas or Kubernetes resources, or even just sending a Slack message. Argo Events also gives us a couple of more features. First, it gives us to filter events with basic conditions, so we won't act upon every event. Second, it gives us to parameterize our triggers based on the events fields. So if the webhook from Stripe contains the address that we need to reach, we can use it to parameterize. And also, it gives us to visualize the event flows. Just like Argo CD shows us applications and application sets, Argo Events shows us the event sources and also our sensors and triggers. So the initial plans was to collect the webhooks using Argo Events and then profit. If we look back at time to the first one of the first slides, we will replace our first question mark with the Stripe integration of Argo Events, listening to webhooks. Then we will use the event bus, which is the Jetstream one, and then we will distribute all of them with a sensor that will trigger a pod that will send the request to all of our dynamic environments. But then we tackled a couple of issues with Argo Events. The first one was the Stripe integration. Once we used the Stripe integration, a pod span up. It went to Stripe, it signed a new endpoint, but then, which is cool, but then once this pod got restarted, from any reason, it went back to Stripe and signed a new endpoint. You remember the limit of 16? Well, it failed because it didn't have a new endpoint to sign. So we went to the docs, we searched for a solution, and we didn't find any. We didn't find anything that will make it work from in front of the same endpoint and will listen to the same endpoint. So instead of that, we used something called Webhook integration, which is just the generic integration. So we configured Stripe ourselves and then used just the Webhook integration. But then we tackled another issue, a bigger one. Jetstream as our event bus, as it went up, it went with basic auth. It based with credentials, but the sensors and the event source didn't got those credentials. We really don't understand why we try to expose those credentials to use them in both the event source and our triggers. But we ended up using something called exotic Jetstream, which is just bring your own Jetstream. And then we could just spin up a Jetstream without basic authentication, so the event source will be able to give us to talk with our event bus, which is our Jetstream. But after all of those and all the flow that went, we tackled a third issue. Our dynamic environment got malformed content. And that's where we understood, well, maybe Argo Events is not our best pick for now. So back to the drawing board. After spending a week on trying to make Argo Events work as we expected, we understood we're gonna go with a different way. We're gonna go with building it ourselves. And that's what we did. We created 2 Go services, one that listened to the webhooks from Stripe, getting them to our Jetstream, which we already managed because Argo Events didn't. And then another one that just listened to the webhooks from the Jetstream and sent them to all of our dynamic environments. By that, we didn't solve only the problem with Stripe. We solved the problem with all of our integration that sends webhooks because we made those 2 services highly configurable. So what have we learned? What have we solved in this adventure? Well, first, now developers can test their features that requires webhooks in all of the dynamic environments. Second, the gap between our staging and production just shrank because all of them get the webhooks. Third, we now can run E2E in parallel, and we don't stack all the developers that need to wait for it. And for last, we did all of it with minimum footprint. It only take like 2 megabytes of memory and nothing of CPU, which is pretty amazing. What can you take from this adventure, though? Well, first, NATS is a great, simple message queue, and I dare you to use it. Second, well, Argo Events is just not always the perfect fit. And lastly, building your own solution today is way simpler than in the past. And I also dare you to try, and maybe even in parallel with going with a product in the market. So here you can join the Friends of Dorothy community, the CNCF one, and if you're asking, yes, we're hiring, so you can also see our career page. Thank you.